All right. Well, hey, today we're going to look at banking a little bit and compound interest and the such. Now, when we're looking at a bank situation here, interest is involved because when you put your money into the bank says, hey, thank you for putting your money here. Now, we're not just going to put it in a box and put it in the corner, but we're going to take it and invest it. And the bank is going to invest it out there in the world and make some of their own money. So as a kind of a thank you or for letting us loan your money, they give you some of that money back, and that's called interest as a thank you. So we've got a situation here where we have a person putting in some money, and it looks like we're going to run this one, Bank West CD, okay? And that's just a way, again, to get some interest from the bank using your money, and so that's this guy. So that's what we find out. So interest is compounded quarterly. Okay, quarterly, that represents every 3 months. It's like a quarter of a year. So that's what quarterly represents. So the bank calculates interest using a rate that is 1/4 of the annual interest rate. So a fourth of it. So Bank West has an annual interest rate of 3.8%. So 3.8%. Divided into 4, that actually quarterly is 0.95%, so under a percent. So let's come back down here. So for the first quarter, our money is put in at 15,820, and the interest is earned by calculating 15,820 times actually it's not 0.95 because that's the percent. It's times 0.0095, and you end up with $150.29. And I tack that on, and I end up with $15,970 because it's the starting principal plus the interest, and that's my ending principal. Well, now as we move into the second quarter, my initial balance has changed. It is now $15,970. Well, I'm going to take my $15,709.20, 15,970 using my calculator, times 29 cents times 0.0095, and I now have an interest earned of 151.72. Okay, I'm going to add that to my initial 970.29, and now my balance is up. Let's make sure I added this right. Yep, so I'm at 16,122. Now, my new starting principal has now changed. Now, we call this compound interest because it's compounding each time. It's not tallied once, but it's built on each time. Now, for those that are interested in kind of speeding this up and going a little faster, we can see how the interest is earned, but if you want to go right over to the ending principal, you can take your 16,122 and multiply it by 100% of the starting principal and multiply it by the interest. So I'm going to take my new amount here, I'm going to multiply it by 1.0095, and it moves me right into my ending principal, 16275.17. And we can see that it keeps moving up. All right, that's how compound interest works. It just keeps compounding and keep building after each other. So a couple things you want to pay attention to when being asked about compound interest is you want to see how often it's being compounded and for how long. So this represents a year. So if I say something is being compounded quarterly for a year, I know that I'm running my math 4 times. Anytime you hear the word compound, you know you're just going to be doing a lot of calculating. So be ready for that. Compound means calculating. All right, let's look at another power here. So we have to raise a power to a power, and that's kind of what we're looking at. Okay, simplify an expression with products. What is the simplest form of n to the half power to the 10th power times 4mn, and that looks like that is, let me pause so I can read what that number is. All right, I found what that tiny little number is. It was -2/3. All right, so this is a power to power. So this is saying n to the half times 10. And then I need to distribute this 3 to all these pieces here. So this is saying 4 to the third, m to the third, n to the, is that negative there? Okay, negative 2/3 times 3, and that's my power to power rule. And let's keep doing our simplifying. So half of 10, so it's n. It's going to end up being n to the 5th. And this is going to stay 4 to the 3rd, which is like 64. And we'll have to move all these around once we get them. We have m to the 3rd, and then we have n. And this is, when I look at this, is negative 2/3 times 3. So 2/3 times 3 ends up being 6/3, which equals 2. Okay, so I got my 2/3. And we could say negative. Negative 2/3 times 3, multiplying my fractions, I end up with negative 6/3, which is negative 2. So it's n to the negative half. I gotta do some more simplifying here. I'm going to lead off with my 64, and I have n to the 5th, m to the 3rd, and because this is means it's small, it's a negative exponent, I'm going to bring it down, so n to the half. Whoa, 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 we got to back up the bus. Back up the bus. Beep, beep, beep. I didn't see something that a student just walked in and said, hold on, Mr. Weber. So I'm holding on. I'm going to erase this because way back here, true, this is negative, but look at, I've got n. So before I move things like that around, I need to combine my like terms. So I have an n to the 5th times n to the negative second. So that's n, 5 minus 2. So that's actually n to the 3rd. So I need to modify something here. So this actually ends up being n to the 3rd. Okay, did you pick up what I laid down just there? N to the negative 2 times 3 ends up being n to the negative second. And then I notice that I have n to the 5th and n to the negative second. And because we're multiplying, I can go ahead and add those exponents, which I subtracted, and I got a 3. So this is my final answer. Sorry if that offered a little confusion, but I'm hoping you can pick up what I just laid down there. Hey, here's a few to try. Press pause. All right. Take a look at each piece here and what's going on. There are the different elements. Now, notice I just had to combine my like terms, which I didn't do in my original example right away. But there we go. And for the last one, C, I noticed that I ended up with a negative exponent. And I don't want to leave that. It just tells me it's small, so I bring it into my denominator. Raising a number in scientific notation to a power. Let's take a look at it. All right, so I'm going to use my initial equation. So this expression, it gives the kinetic energy in joules of an object with a mass of m traveling at a speed of v in meters. So let's look at the two things. Our kinetic energy of some experiment that's happening. Oh, it's an unmanned jet, of course. Why not? Like a hovercraft. Ooh, like a drone. Ooh. Well, this is its mass, okay? So I know what the mass is, and it's traveling at a speed, so I know the speed because v is telling me that v in meters. Okay, so I have to plug all this in. So it's 1/2 times the mass, which is 1.3 times 10 to the 3rd, times v, which is 3.1 times 10 to the 3rd, and that is squared. All right, let me clean this up a little bit. So I have 1/2 times 1.3 times 10 to the 3rd times, now this square is affecting both things, times 3.1 squared times 10. Now this is 3 to the 2nd power, so 3 times 2, so it's going to be to the 6th. Okay. Now I have these bases, and I can bring those together, and because of the product rule, I can add them up, so I know it's going to be times 10, 6, 7, 8, 9 to the 9th. And then on this side of it, I've got all these pieces. I've got 1/2 times 1.3 times 3.1 squared. And if I multiply all those together, 0.5 times 1.3 times 3.1 squared, but I'm going to make sure that this square is only, the 3.1 is the only thing that's being squared. In this case, I get like 6.2465 times 10 to the 9th. All right, why don't you give it a try? Same rule, 1/2 mv squared with a different mass and a different speed. See what you get. right. Work this all out. More likely you ended right here, which is almost in scientific notation, except for this needs to be between 1 and 10. So I moved my decimal over and I had to compensate by making my exponent moving it up 1. Nice. Excellent. Well, hey, I'm going to put on some funky socks and go dance with my neighbor's grandma.